Okay. So SOHCAHTOA, on any right triangle, there's a 90-degree angle. Okay? And then somewhere there's an angle, and we can measure, there's 3 angles on a triangle, but if you pick one and call it theta, there's an angle theta. Now, the side of the triangle across from the angle is the opposite side. So here's my angle theta, and this is my opposite side. The side across from the 90-degree angle is the longest side on the right triangle. We call that the hypotenuse. And the one left over is called the adjacent. Now this is on any right triangle, but we're gonna focus on 2 specific right triangles. We call those the special cases at first, and then we'll apply this knowledge to everything else. So what SOHCAHTOA reminds us is the relationship or ratio of 2 of these 3 sides relative to the angle. So if I say sine of theta, we have OH. The SO means sine of theta is equal to the opposite over the hypotenuse. The CA is cosine of theta is equal to the adjacent over the hypotenuse. TOA means that tangent of theta is the mathematical relationship of the ratio of the opposite over the adjacent. Okay? Does that make sense to you guys? Now we're going to memorize a couple of things, and so what I'm going to do is I'm going to come down here, and I think you guys already know this stuff. So we're going to consider this triangle. So if I start with this triangle, and I take this little angle here that I call theta, this is a 45 degree angle triangle. So this one, theta is equal to 45 degrees, or theta is equal to pi over 4, because 45 degrees is pi over 4. Okay? Well, then this angle is also 45 degrees, because what's the sum of the interior angles on a triangle? 180. So this is 90 degrees, this is 45, so this is 45. So some textbooks refer to this as the 45 degree 45 triangle. Now that's a specific type of triangle. Can somebody tell me what type of triangle that is? That's an isosceles triangle. And one of the properties of isosceles is that if this is 1, then this must also be 1. In other words, these 2 sides are congruent. Right? Well, if I do the Pythagorean identity, I get the square root of 2. So on the 45 triangle, whatever this length is, it's 1 times x. This length has to be the same. And the hypotenuse will always be the square root of 2x. So the reason I write the x down is because sometimes we'll have like 3 root 2. That means that the other side lengths are going to be 3, right? 3 times 1. So that's the ratios. So now if I apply this, if this is theta, what side is this? The opposite. That means that this must be the adjacent, and this must be the hypotenuse. So now, if I say sine of 45 degrees, well, that's equal to the opposite over the hypotenuse, which is 1 over the square root of 2, right? Can we leave radicals in the denominator of a fraction? No. You guys are shaking your head no, but I want you to say no. No? Okay, good. So no, how do I fix that? How do I fix that at 8 o'clock in the morning? Say it. Yeah, so what I want to do is, the fancy math word is rationalize the denominator, but you multiply it by itself, right? So you can square it. So you say the root 2 of 2 times the root 2 of 2, but remember, whatever you do on the bottom, you have to do on the top. So then sine of 45 degrees, whoops, sine of 45 degrees is equal to root 2 over 2. Which, by the way, is the same as sine of pi over 4. Does that make sense? You guys with me so far? So then, what's cosine? Well, then cosine of 45 degrees would be the adjacent over the hypotenuse, which is still what? 1 over root 2, which when we rationalize would be root 2 over 2, correct? Does that make sense? Yeah? So then that's also the same as what? Cosine of pi over 4. Okay? So then tangent of pi over 4 is the same as tangent of 45 degrees, which is equal to the opposite over the adjacent, which is equal to 1 over 1, which is equal to 1. It's a lot of stuff, isn't it? You guys with me so far? Okay, so let's regroup here. So I said that sine of 45 degrees is equal to root 2 over 2. And I said that cosine of 45 degrees is equal to root 2 over 2. And then I said that tangent of 45 degrees is equal to 1 over 1, which is just 1, right? You guys with me? Okay. Now, that's one way to represent it. Those are 3 of the 6 basic trig functions. So, SOHCAHTOA sine of theta is equal to the opposite over the hypotenuse. Cosine of theta is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over the adjacent. Are you guys writing all this down? Because when I look out, you guys are looking at me, but I don't see pencils moving. Make sure you're writing all this down. It's not the same in the book. Now, these have what we call reciprocals. So these are 3 of the 6 basic trig functions. The reciprocal of sine is cosecant. And so we just flip the opposite and hypotenuse. So that is the hypotenuse over the opposite. The reciprocal of cosine is secant, which is the opposite over, or not the opposite, the hypotenuse over the adjacent, and then cotangent of theta is equal to the adjacent over the opposite. Right? So if that's the case, then I could also represent these 2 sides by saying cosecant of 45 degrees would be what? Well, remember, it was 1 over root 2, so this would be like root 2 over 1, which is just root 2. Secant of 45 degrees is equal to root 2. And cotangent of 45 degrees is equal to 1. Is that right? Does that make sense? These you need to memorize. By the way, if you plug this in a calculator, it's always going to be 0.077. Root 2 over 2 is 0.077. This in a calculator is always going to be 1.414. So get used to seeing those decimals. My calculus students think I'm a genius because I'll say, sine of 45 degrees is, what is that, 0.707? I'm like, Mr. Adams, how did you know that? I memorized it. Well, that's just one of the 2 special triangles. Okay, you guys, any questions about this? All right, so now let's do the other special triangle. And we'll figure out what this is, the 60-degree angle, and this is the 30-degree angle. I wrote those in the wrong spot. Okay? All right. At my notes, I had the triangle turned another way. And I tried to write things from the notes, and then I realized that I didn't orientate my triangle properly. We'll do the other one. So based on that, what's sine of 60 degrees? By the way, 60 degrees is equal to pi over 3. So, now let's list all these things. Sine of 60 degrees is equal to sine of pi over 3, which is equal to the opposite over the hypotenuse, which is what? Root 3 over 2. Okay? Cosine of 60 degrees is equal to cosine of pi over 3, which is equal to the adjacent over the hypotenuse, which is 1 over 2. Is that right? Tangent of 60 degrees is equal to tangent of pi over 3, which is equal to the opposite over the adjacent, which is root 3 over 1, which is root 3. Well, let's continue. So then what are the reciprocals of this? Well, based on this information, if I were to plug all this in, we have the opposite over the hypotenuse, which is root 3 over 2. We have the adjacent over the hypotenuse, which is 1 over 2. We have tangent, which is the opposite over the adjacent. So, since these are just the reciprocals, in this case I would have root 3 over 2. And when I hit the top and bottom with the square root of 3, I would have 2 root 3 over 3. This would be 2 over 1. And this would be 1 over root 3. Again, when I hit the top and bottom with the square root of 3, I get root 3 over 3. Okay? So the opposite now is 1, so I'm going to have 1 over the hypotenuse, which is 2. And then I'm going to have cosine, which is the adjacent over the hypotenuse, which is going to be root 3 over 1. And then the tangent is the opposite over the adjacent, which is going to be 1 over root 3, which is really root 3 over 3. Okay? Oh, this isn't 2. This is 2, not 1. I'm sorry. Sure. So this would be, and then this would be 2. Okay? I wrote that down wrong because it's the adjacent over the hypotenuse. So now we reciprocate those. This becomes 2 over 1. This becomes 2 over a, which is the square root of 3, which if we rationalize the denominator, we end up with 2 root 3 over 3. And this one just becomes the square root of 3 over 1. Okay? Any questions on that? Yes?
So define like the cosecant, secant, and cotangent. Would you just use like the negative 1 by the cosecant?
Yeah, I'm going to show you that now. So what we want to do is, if we're in our calculator, your calculator, if you'll notice, only has the first 3 trig functions. So if I want, we just found out, we want to check and see what mode we're in. So right now I'm in degree mode. And we just did 30 degrees. So I said that sine of 30 degrees was 1/2, which is 0.5. Well, what did I say the reciprocal of that was? Well, if we look, the reciprocal of that was 2, right? So how do I get that up? Well, how do I figure that information out? Well, what I could do is I could reciprocate by saying 1 divided by sine of 30 degrees. Now, when I do this, what I'm really doing, this represents the reciprocal of cosecant of theta, or cosecant of 30 degrees, in this case. Now, when I hit enter, what did we say the answer should be? The answer should be 2, right? It's 2. Does that make sense how I did that? So then let's keep playing around with this and see what we can come up with. I'm going to slide this over just a little bit so we can see things a little better. So then if that's the case, we said that cosine of 30 degrees is root 3 over 2. And that's true because if I take the square root of 3 and divide it by 2, you get the same decimal. So we're right on that one, right? So now if I wanted to find out the decimal approximation of 2 times root 3 over 3, I could just say 2 times the square root of 3 divided by 3, and that'll give me this decimal, or that should be the same as 1 divided by cosine of 30 degrees. Hey, guess what? It is. Lastly, we said the tangent of 30 degrees, which should be root 3 over 3, which is 0.577. So if I plug in tangent of 30 degrees, I should get 0.577. See what I did there? Then we say cotangent will be the reciprocal of that, which is root 3, which is 1.73. So I'm going to say 1 divided by, oops, no, I want a tangent. 1 divided by tangent of 30 degrees should be 1.73. Okay? Does that make sense to you guys? Okay. Now, what is that in radians? Well, we said that the relationship we said that when theta is equal to 30 degrees, well, let's see, pi is 180 degrees. What am I dividing 180 by to get 30? 6. So pi divided by 6 should be the same thing, right? So now that I've put my calculator in radian mode, tangent of pi divided by 6 should be the same as tangent of 30 degrees, or 0.577. And it is. Just like sine of pi divided by 6 should be equal to 1/2, or 0.5. And cosecant, which is 1 divided by sine of pi divided by 6, should be 2. And it is. So you're going to have to know how to bounce back and forth. If you memorize, and I would say about 95% of your homework problems are based on these two triangles. If you memorize those triangles in the side lengths, which is easy, for the 45-45 it's 1, 1, root 2. And in the other one it's 1, 2, root 3, where 1 is the shortest side. And remember that the shortest side is across from the shortest angle, which is 30 degrees. Okay? That's it for example 1 and 2. Are there any questions?